All right, in this section we're going to work on simplifying algebraic fractions, and since we're experts on factoring now, it will be a pretty straightforward process. When we simplify an algebraic fraction, we start by factoring the top and the bottom, and then we cancel common factors just like we would with numerical fractions. So let's begin. In this example, we've got 2x squared plus 8x, and we're dividing that by x plus 4. Now we cannot cancel over addition. This x squared does not cancel with the x in the bottom. The 8 there does not cancel with the 4 that's in the bottom. But what we want to do is write the top and the bottom in factored form. The bottom is already factored, right? That's just 1 times x plus 4. Up top, we could take out a factor of 2x. And then what's left inside is an x plus 4. Now there's a common factor of x plus 4, and we can cancel that because now we're canceling factors. You can cancel things that are being multiplied. And what we're left with is 2x over 1, or just 2x. Let's do another one. We're going to simplify this fraction. We begin with factoring. Up top, you'll notice that this factors as. Now if you want to try the factoring before I have a go at it, you might want to pause the video. But this will factor. We need an x and an x, and then minus 2, and you could check that'll give us the minus 4x in the middle that we need. And the bottom is a difference of squares, so this is x plus 2, x minus 2. Now we can factor this common factor of x minus 2, and we are left with x minus 2 divided by x plus 2. And now that's as far as we can go. Remember that we cannot cancel over addition. So those x's do not cancel. Those 2's will not cancel. Just this is as far as we can go. Let's try another. Again, if you want to try the factoring on your own before I have a go at it, you might want to pause the video. The bottom will factor as y plus 4, y plus 1. You can do a quick check and see that that will give us the plus 5y that we need in the middle. Up top, I'm going to start by factoring out a y. There's a common factor, and then we have 3y squared plus 7y plus 4. And then we can continue factoring that trinomial. So let's see, setting up our parentheses here, we've got 3y and y. Now, at the end, we have to have things that multiply out to a positive 4. I'm pretty confident it's going to be a plus and a plus, given that we need a plus 7y in the middle. So plus and plus. So it's either 4 and 1 or 2 and 2. And it should be 4 and 1 here, I think, because if you do a quick check, there's a plus 4y plus 3y, and that gives us the plus 7y that we need. Now that we've factored as far as we can cancel out the y plus 1, and then we're left with y times 3y plus 4 divided by y plus 4. That is as far as we can go. Y plus 4 and 3y plus 4 are totally different factors, so they're not in common, and we cannot cancel over addition, so we can't cancel the y's. Once in a while we might notice that we have factors that are really close, but they're not quite matching. This can happen sometimes when we're just reversing the order of subtraction. So note that the negative of x minus y, you could distribute that minus sign and it simplifies to y minus x. So if I notice that I might get a common factor if I were simply able to reverse the order of subtraction, you can do that just by factoring out a negative 1. Let's take a look at this example. X squared minus 1 divided by 1 minus x. So x squared minus 1 is x plus 1 times x minus 1. In the bottom we have 1 minus x. And that is really close to x minus 1. We've just reversed the order of subtraction. So I'm going to take out a negative 1. This is the negative of x minus 1. You could double check. If you distribute that negative 1 through the parentheses, you get negative x plus 1, which is equal to 1 minus x. Now we can cancel the x minus 1. We end up with x plus 1 over negative 1, which it's pretty unconventional to leave it like that. Dividing by negative 1 is the same as multiplying by negative 1. So this is negative x plus 1 or negative x minus 1, and either of these would be okay. Okay.